Hello folks, we are back with the next video. The previous one we did till question number 6 where we had several subparts. We tried to decide whether it is an increasing function or decreasing function. So right now we are up with this next question number 7, which says that show that y equal to log of 1 plus x minus 2x by 2 plus x for x greater than minus 1 is an increasing function throughout the domain. You have to show that it's increasing function in the domain that they have described. They have told us a domain x greater than or equal to minus 1. In that domain you have to show that it's increasing function. Pretty easy, right? We will just we know that for every time that we have increasing or decreasing function, we have to first get the derivative and decide the critical points if you're not aware of the interval. But here now they have told about the interval, so there's no need to go on and find the critical point. That's not required. So it's enough if we just check in that given interval whether it is increasing or not. So that's all. Our work is quite reduced. So let's get back directly. For the given function, let's find dy by dx. Let's find the derivative, and that's how we're going to proceed. The y is given to us, so let's find the derivative dy by dx. Not like before earlier, all these time we were doing all polynomial functions and all that, quite easy to do. But here now it's a combination of two functions. This function is a rational function over here, and this is a logarithmic function. So we have to get the derivatives. Log x, we all know derivative is 1 by x. And this is log 1 plus x, which is a linear polynomial. So log with a linear polynomial, log of a linear polynomial function will behave just like log x. Now, so how log x is what derivative log x is giving, this is also going to give the same derivative, so doesn't put us in much of trouble. So it's easy to get the derivative of log 1 plus x. If had it been log x, the derivative was 1 by x. So derivative of log 1 plus x will be 1 by 1 plus x, just like that. You know how you get the derivative of log x, just that way. So also we have this rational function. Now, rational function means we know that every function which is of the type of a quotient u by v, then you use the quotient rule and get the derivative. So here directly we can go for the derivative by using the quotient rule. You can keep 2 out. Now you can keep 2 out. Let the 2 be out, and let's get the derivative of this function. Denominator into derivative of the numerator minus numerator into derivative of denominator. Of course, we need not write all this, but just to give you an idea as to how the derivative is. So let's see what comes. X plus 2 as it is, derivative of x we all know is 1. So x plus 2 into 1 is x plus 2 itself. So also x stays as it is. Derivative of x plus 2, 2 has got no derivative, it's a constant, so 0 derivative. And derivative of x is 1. So here also it's x into 1 by x plus 2 the whole squared. Let's further expand this. Minus 2 times x plus 2 minus x by x plus 2 the whole squared. Luckily the x is getting cancelled. 1 by 1 plus x, 2 into 2, 4 by x plus 2 the whole squared. Since we have to show that this function is increasing whenever x is greater than minus 1, we need to show that this term is positive. So for that, let's further work on it. And we know here the denominator is x plus 1. Here the denominator is x plus 2 the whole squared. Let's equalize the denominators and then look at the fraction as such and then decide whether it is increasing or not. So for that purpose, we will multiply this by x plus 2 the whole squared, both in the numerator and denominator, so as to equalize the denominators. So also here you can multiply by x plus 1 both in the numerator and denominator in an attempt to equalize the denominators. So you are having the denominator now as x plus 2 the whole squared into x plus 1. Here it is x plus 2 the whole squared, and here it is 4 times x plus 1. We are just equalizing it. Now we'll see how we can expand this. X squared, let's have this expanded. X squared plus 4x plus 4 minus 4x minus 4 by x plus 2 the whole squared into x plus 1. You can have the plus 4x minus 4x plus 4 minus 4 cancelled, so that we are left with x squared by x plus 2 the whole squared into x plus 1. Now for us to show that the function is increasing on x greater than minus 1, you just need to show that at the value of x greater than minus 1, the dy by dx is positive for all those points in that domain. And that's pretty easy. Why? Because for dy by dx, when we observe, here it's a square which is always going to be positive. Square we know is always going to be positive. X plus 2 the whole square is also finally a square which is going to be positive. And then x plus 1, if that is positive, then the entire thing, this entire dy by dx will be positive for x greater than minus 1. So we only need to ensure whether this is positive. If this is positive, then our work is done. So let's see whether how that can be done. Here, for x greater than minus 1, you add 1 on both sides. Why? Because you want x plus 1. So we'll add 1 on both sides. So you're getting x plus 1 to be greater than 0. So that's exactly what I said. If we have this as positive, then this entire thing is positive, and that way your dy by dx can become positive. So uh, x greater than minus 1 is leading us to this. So therefore you get, therefore x squared is positive and x plus 2 the whole squared is also positive, and like that dy by dx is also greater than 0 if x is greater than minus 1. Only if x is greater than minus 1 that is happening. So that's how we can show that it is increasing. That's what they're asking us. Show that it is increasing throughout the domain. Yeah. So that's it. We've proved it. Hence proved. We'll write hence proved because we've done whatever that they have asked us. That's all for this video, and then we get, it's an important question. Where when it comes in the board exam, the interpretation has to be correct. Though it's very simple, but the interpretation has to be really correct, and this is how it happens. So it's quite important from the understanding and the presentation point of view. So with the next problem, I think we can meet in the next video. Thank you.